In this capstone, we'll turn a realistic enterprise AI scenario into clear, architecture-ready requirements. We'll connect business goals, AI capabilities, risks, stakeholders, and compliance drivers, then use that analysis to prepare for ISO IEC 42001 aligned design and certification evidence. You've built the pieces: ISO 42001 foundations, governance, architecture controls, MLOps and LLMOps, and certification readiness. Now we'll bring them together in a realistic enterprise case, where you decide what needs governance, who owns it, and which risks should shape the solution. We'll make ISO 42001 concrete through a Capstone scenario, a shared enterprise AI platform used by several business units. It supports predictive analytics, document intelligence, and a generative AI assistant, so the risks are not all the same. You'll examine the technical architecture, but also the management system around it: who owns data, who approves use, how providers are controlled, and how compliance teams maintain oversight as the platform scales. Before defining architecture, data controls, or model governance, we need the business reason for the platform. Enterprise AI is not one capability. It responds to several strategic needs: better forecasts, faster decisions, less manual document work, more productive employees, and stronger evidence of trustworthy AI. Each goal creates different requirements. Predictive analytics needs reliable data pipelines and monitoring. Document automation needs workflow integration. A GenAI assistant needs secure knowledge access and usage guardrails. Governance needs auditability, accountability, and policy enforcement. Good architecture ties every technical choice back to these outcomes. The AI portfolio should be treated as three different operating models, not one generic technology. Predictive analytics works with structured data to estimate outcomes, so bias, drift, and decision thresholds matter. Document intelligence turns messy files into usable information, so extraction accuracy, traceability, and exception handling become central. GenAI assistants generate answers and content, so hallucination, data leakage, and prompt controls need attention. The AI management system is the common governance layer, but the controls are not identical. Each capability needs its own risk treatment, monitoring, human oversight, and evidence that it is working as intended. The scenario also has several connected technical layers. Data enters from internal, cloud, and third-party sources, then moves through ingestion and preparation before reaching feature stores, model services, vector databases, document processing, and the LLM gateway. User applications consume the outputs, but they also create new prompts, logs, and risks. Around this flow are external dependencies, such as cloud platforms, foundation model providers, and SaaS tools. ISO 42001 governance must be embedded at the control points: identity, monitoring, model registry, prompt management, policy enforcement, and audit evidence. Requirements extraction is the bridge between business intent and buildable AI design. Start with scenarios and stakeholder goals, then translate them into functional needs, what the platform must actually do. Next, define non-functional qualities like latency, reliability, scalability, usability, explainability, and resilience. Then capture governance, compliance, security, data, and operational obligations. The critical move is tracing each requirement to risk implications, controls, and evidence artifacts. That traceability prevents vague aspirations from becoming unsupported architecture choices. It also gives auditors, operators, and executives a common language for judging whether the AI platform is fit for purpose. Functional requirements translate the AI strategy into concrete system behavior. For predictive analytics, define what forecasts, scores, recommendations, or classifications the platform must produce, and for which process. For document intelligence, specify how documents are ingested, classified, extracted, summarized, validated, and routed. For a GenAI assistant, define the questions it can answer, the knowledge it can retrieve, and the workflow support it may provide. Strong requirements also name user roles, triggers, inputs, outputs, decision points, and where human review is required. This creates clarity for delivery, governance, and the ISO 421 system inventory. Non-functional requirements are the promises the platform must keep while it delivers AI capability. They translate trust into measurable operating targets. For software, that means latency, throughput, uptime, recovery, and maintainability. For AI, it also means accuracy, precision, and recall, hallucination limits, drift thresholds, robustness, and explainability. Usability matters too, because humans still need to supervise, question, and safely override the system. Make every quality expectation testable. Define the metric, set the acceptance threshold, assign an owner, and identify the evidence source. If you cannot measure it, you cannot govern it reliably. ISO IEC 42001 turns AI governance into a management system, not a one-time checklist. In the Capstone, ask who owns each AI system, who accepts risk, who approves models, and who monitors performance after release. Then look for policies that make those decisions repeatable. Development, deployment, use, oversight, incidents, and change control. Evidence matters as well. The organization should be able to show its aim scope, AI inventory, risk and impact assessments, implemented controls, and management reviews. The key idea is traceability. Business use of AI must connect to accountable decisions, measurable controls, audit-ready documentation, and continual improvement. Enterprise AI requirements do not come only from product goals. They also come from external constraints that must be designed in from the beginning. Regulations may require privacy controls, security safeguards, explainability, localization, or sector-specific approvals. Contracts can add limits from customers, cloud vendors, data providers, model providers, and outsourcing partners. Ethical expectations add another layer. Fairness, transparency, human oversight, misuse prevention, and harm reduction. The key move is translation. Each obligation becomes an architecture decision, an operating process, a monitoring control, and evidence that can survive audit or review. The requirements also need to cover security, data governance, and operations, not just model accuracy. Security defines who can access systems, how secrets are protected, how endpoints are defended, and how threats like prompt injection are detected. Data governance answers whether data is permitted, classified, traceable, high quality, minimized, and retained appropriately. Operations ensures the service can be monitored, alerted, rolled back, escalated to humans, and managed through its lifecycle. The principle remains traceability. Every requirement should connect to a risk, a control, an owner, an operating procedure, and evidence that proves the control is working. A clear aims boundary answers a practical question. What do we actually control? Start with organizational scope. Which business units, locations, teams, and AI services are covered? Then define technical scope. Models, applications, data pipelines, infrastructure, APIs, vendors, and monitoring tools. Anything outside the boundary still matters if the aims depends on it, so document the interface, responsibility, and evidence needed. Exclusions are allowed, but only with a clear rationale. This boundary becomes the basis for control selection, evidence collection, audit testing, and certification readiness. ISO IEC 42001 treats an AI platform as a shared accountability system, not just a technical asset. Identify who influences it, who operates it, who governs it, who depends on it, and who may be affected by its outcomes. Then assign ownership clearly. Systems, datasets, models, risks, controls, incidents, approvals, and evidence all need named responsible parties. This analysis also drives consultation and transparency. If individuals, customers, communities, or regulators can be affected, their needs shape impact assessments, human oversight, complaint paths, and risk treatment priorities. Clear stakeholder mapping prevents gaps, duplication, and unmanaged accountability. In this topic, you turned a complex AI scenario into structured implementation inputs. You clarified requirements across functionality, governance, security, data, operations, and regulation. You define scope and boundaries so governance, evidence, audits, and improvement are clear. You also mapped stakeholders and ownership. Next, these inputs become architecture, control mapping, and finally, a certification readiness package.